Let us see another example. Find HCF of x square minus 1 whole square, x plus 1 and x square minus 1. Here 3 polynomials are given and we have to find HCF of these 3 polynomials. Okay. First of all, we will write f of x equal to x square minus 1 whole square, g of x equal to x plus 1 and p of x equal to x square minus 1. Okay. Now we will write f of x first. F of x equal to x square minus 1 whole square. Okay. Now I know that x square minus 1, I can write it like x square minus 1 square whole square. That is x square minus 1 square means x plus 1 in one bracket, x minus 1 in another bracket, whole square means here will be square to the both terms. Okay, means that is equal to x plus 1 into x plus 1 into x minus 1 into x minus 1. This is the value of f of x. G of x, it is equal to x plus 1 and p of x equal to x square minus 1 means x square minus 1 square means x plus 1 in one bracket, x minus 1 in another bracket. Okay, here HCF, now we want to find HCF of 3 terms, therefore we will write the term which is common in first, second and third term. It is easily observable that x plus 1 is common in all these 3 terms, therefore HCF of the problem is x plus 1. Okay, so this is one simple example. Now we will see the next example. Example number 4. Find HCF of xy plus x square, comma xy minus x square and x raised to 4 minus x square y square. Okay, there are 3 terms. We will write them as f of x equal to, our first term is xy plus x square. Okay, you can clearly observe that you can take x common from them. X equal to, you will get y plus x. Okay, second term is g of x. We will take it equal to x y minus x square. Okay, so what you can take common from them, that is x bracket में y minus x and q of x equal to x square, x raised to 4 minus x square y square. Okay, x square you can take common, you will get x square minus y square equal to x square in one bracket, x plus y into x minus y. Okay, so what will be the HCF? अभी 3 टर्म में से कॉमन निकलना है, तो we can write the term which is common in all 3 of the term. Now you can see x is common in all 3 of the term, y plus x is common in 2 terms and y minus x with minus sign, it can be taken common from 2 terms only, not from all 3 terms. So we will take only the term which is common in all 3 of the polynomials, that is x. So HCF of the problem is x. Okay, now I hope you understand the concept of HCF of polynomial. Now we are going to consider LCM of polynomial. LCM means what? Of polynomial. LCM means lowest common, lowest or least, you can also say, common multiple. Least common multiple means what? If I want to find a least common multiple of any number, I take the product of common multiplied by uncommon numbers. Okay, that is our normal method. Now we will see, find the LCM of polynomial. Find the LCM of, we will consider our first example, 30x square and 36x cube. Okay, let us write here 30x square. We have seen it. 30 means 2 into 5 into 3 into x into x. Okay, and 36x square x cube means 36 means 3 into what? 3 into 3 into 2 into 2. Okay, into x into x into x. Now we will write the common terms. Common terms are 2 is common, 1 3 is common, and x. Okay, means 2 into 3 into x into x, that is common is 6x square. Okay, now we will write uncommon numbers, uncommon factors. What is uncommon? Here 5 is uncommon and 1x is uncommon. In this term 1 3 is uncommon, then 2 is uncommon and 1x is uncommon. That is equal to 5 3s are 15, 15 2s are 30 x square. Okay, now LCM of the term equal to common multiplied by uncommon, common multiplied by uncommon. So common is 6x square multiplied by uncommon is 30x square. No, here 1x is not common. This x is not common here. It will be x cube. Uncommon term will be 5 into 3 into 2 into x, 30x. Okay, so that will become 36 of 180 x cube. Okay, so this is LCM of 30x square and 36x cube. Okay, now we will see some simple examples of the type. One more example of LCM and you will get the concept clearly. Find the LCM of 27 a raised to 5, 81 a raised to 10 and 3 raised to 4 a raised to 10. Okay, how to find LCM of these three numbers? We will write it one by one. 27 a raised to 5 means what? 27 means 3 into 3 into 3 into a raised to 5 means a into a into a into a into a. This is one complicated way we are writing here. 87 a raised to 10. Now I will not write a 10 times. 87 means 3 into 3 into 3 into 3 into a raised to, I will write it like this, a raised to 5 multiplied by a raised to 5. Why? I don't know. Third number is 3 raised to 4 a raised to 10, that is 3 into 3 into 3 into 3 into again a raised to 5 into a raised to 5. Now we will write common. What is common? These three are common. 3 into 3 into 3 3 times into this is a raised to 5, this is a raised to 5, this is a raised to 5, a raised to 5, this is also common. Okay, and what is uncommon? This one pair of 3 is uncommon. I will write it only once, not 2 times. 3 into this a raised to 5 is also common. A raised to 5 means LCM will be common multiplied by uncommon. 3 into 3 into 3 into 3 into a raised to 5 into a raised to 5. Okay, that will be equal to 3 raised to 4 a raised to 10. 3 raised to 4 यानी 81 multiplied by 3. 3 into 3 9. 1 minute. 3 raised to 4 means 81 into a raised to 10. So this is our answer. Another method of solving, suppose I am having numbers x raised to 5, x raised to 3 and x raised to 2. Okay, what is the LCM of these three? LCM is always of higher power. Means if there is x raised to 5, x raised to 3 and x raised to 2, then LCM will always be x raised to 5. In the same manner, what will be the HCF without doing calculation? HCF will be always with with least power. Means in this case, what will be the least power? X square. Okay, so LCM is x raised to 5 and HCF is x square. Okay, we will see another example. X raised to 6, x raised to 5, x raised to 11. What will be LCM? Largest power, x raised to 11 will be LCM, and what will be HCF? The smallest power, x raised to 5 will be HCF. Okay, now there is a relation between HCF, LCM and given polynomial. What is that relation? That we will be seeing now. Relation between HCF, LCM and product of polynomials. It is very simple. You have seen this relation, polynomials, in terms of numbers. You know that product of numbers is equal to HCF of that number multiplied by LCM of that number. In the same manner, product of polynomials, product of two polynomials, okay, 2 or 3 is equal to HCF of that polynomial multiplied by LCM of that polynomial. Means if one polynomial is P of x and another polynomial is Q of x, then their multiplication will be equal to the HCF of P of x and Q of x multiplied by LCM of P of x and Q of x. We will verify it by considering a problem. Okay. See, our problem is f of x equal to x plus 1 square, x plus 2 and x plus 3, and g of x equal to x plus 1, x minus 1 square and x plus 2. Okay. Now the product will be product of these two things. You will get f of x into g of x. That will be equal to, if you multiply, there is only multiplication sign here, so it is easy multiplication. X plus 1 square into x plus 1, that will become x plus 1 cube. X plus 2 into x plus 2 will become x plus 2 square. X minus 1 square multiplied by x plus 3. Okay, this is product of these two terms. Now we will find HCF of two terms. HCF means common. 1x plus 1 is common here. X minus 1 is not common. X plus 2 is also common. Okay. Now we will find HCF means these are also common terms. What are common terms? X plus 1, x plus 2. Now we will write uncommon terms. Uncommon terms, now see. 1x plus 1 was common. 1x plus 1 is remaining. X plus 2 is common. X plus 3 is there. And x minus 1 is also there, which is not common. Okay. Now common multiplied by uncommon will give you LCM. That is equal to x plus 1 into x plus 2 into x plus 1 into x plus 3 into x minus 1 square. Okay. So that will become x plus 1 square multiplied by x plus 2 multiplied by x plus 3 multiplied by x minus 1 square. This is your LCM and HCF. If you multiply these two terms, I will write it here, HCF multiplied by LCM इक्वल टू, देखो इन दोनों की मल्टीप्लिकेशन आप करोगे, यहाँ पे x प्लस 1 एक बार है, यहाँ पे x प्लस 1 का स्क्वायर है, मीन्स दैट विल बिकम x प्लस 1 क्यूब, x प्लस 2 का स्क्वायर है, यहाँ पे HCF में x प्लस 2 है, यहाँ पे नीचे एक h प्लस 2 है, तो इट विल बिकम x प्लस 2 का स्क्वायर, x माइनस 1 स्क्वायर दो बार है, और x plus 3 is 1 times. Okay, so you can see that product of two numbers and HCF and LCM of the same numbers is always equal to each other. Okay, so HCF into LCM equal to product of two polynomials. Okay.